So I'm going to give you the next example. I'll give you one more example so that you can understand it. But again, I'll give you my notes in description. You can download it from there, containing about many examples and the problem you can solve and help you to understand better. So that's how much effort you make. That's important. It's an excellent way of learning because you can revise it. You can check the video again till you understand it. So we are going to discuss this video, this example. We're having an initial value problem. We have the differential equation and we have the initial condition. So this makes initial value problem. And when we solution, we say the solution of the initial value problem will be a particular solution. So we separate the variables again, but here we having e to power x minus y. So it's the exponential function. We're having e to power m plus n. We get e to power m into e to power n. Where e to power m minus n is e to power m into e to power minus n, and we can write here e to power m over e to power minus e to power n. So we can have different formulas we can discuss. I think you know the exponential one. So I just use it. We can separate the variable. We can write here 1 plus y dy is equal to e to power x e to power minus y into dx. So we can write this equal to 1 plus y dy is equal to e to power x over e to power y dx. Multiply e to power y, we get here 1 plus y e to power y dy is equal to e to power x dx, and this is my variable separable form. So I can just integrate it. I get here 1 plus y e to power y dy. I have the integral e to power x dx. Now we know the integral of e to power x dx is equal to e to power x. So then I just told you that we can solve this integral. For example, I have here 1 plus y into ey by parts, but I took it here 1 plus y and e to power y. I differentiate it, I get here 1. I integrate here, I get e to power y. I differentiate it, I get 0. I integrate it, I get e to power y. So here I multiply with plus sign, and here multiply with minus sign. So I get the integral of this one is 1 plus y e to power y minus e to power y is equal to e to power x plus constant c. So we can solve it very easily when differentiating this one. Then here with the plus sign, here minus sign. So we get here 1 plus y e to power y. Simplify this one. I get here e to power y plus y e to power y minus e to power y is e to power x plus c. So when we simplify this, what we get? This e to power y is cancelled e to power y. I get here y power y is equal to e to power x plus constant c. This is my general solution. So we are given the initial conditions that y is 0 when x is equal to 0. Use this initial condition. I substitute here. I get 0 into e to power 0 is e to power 0 plus c. So e to power 0, we have the e to power 0, e to power exponential to any value, 0 will be equal to 1. So get here 0 is equal to 1 plus c. This gives me c is equal to minus 1. Substituting here, I get here y e to power y is equal to e to power x minus 1 is my particular solution. I have the general solution for the differential equation, and we given the initial condition, then we get the particular solution. We're going to solve this example. We're having the differential equation, that is dy by dx is equal to root of 1 minus y over y. To look at, it's very simple. So we separate the variable. So we get here y or 1 minus y root dy is equal to dx. But we want to integrate it, here we need the substitutions. That's not simple. So our substitution will be, in this case when we are going to solve it, we get here y is equal to sine square u. What's my dy? My dy is 2 sine u cosine u du. And then we having 1 minus y square. So 1 minus y will be equal to 1 minus sine square u, and we know this is equal to cosine square u. So this is my substitutions. I take my substitution. Now number one, I will like to say this is my separable form. I can just write the integrals, my variable, separable form. To solving, I will make the substitution. To get here integral, I have the root sign, and root for root you can see we're having a, b into the root. This is equal to root of a into root of b. We're having root of a over b. We can write as root of a or root of b. So we use this one, and we can write our integral, and we just take the root sign for, we get here root of y, and root of y is versus y is sine square u, and root of 1 plus y square, 1 minus y square, 1 minus y is cosine square u. And what's my dy? My dy is 2 sine u cosine u into du. And the left hand side, right hand side is our only dx. Now we simplify this one. We get here sine u, root is cancelled with square. We have in cosine u, we have 2 sine u cosine u du is integral dx. Now you can see here our cosine u is cancelled cosine u. We get 2 sine square u du is equal to dx. So having sine square u, we can write this one by using the formula that we having this as cosine square u. I can have the formula for this one. That is, I can write here sine square u is equal to, in 2u formula, is equal to 1 minus cosine 2u, 1 over 2 and 2 multiply here. 2 sine square u is this one. So you can write here this equal to 1 minus cosine 2u du is equal to dx. Here we are using techniques of integration. Now we integrate this one. Integral of 1 is u, and here we get integral of cosine is minus sine. We get here sine 2u, and then we have of 2 is we get here over 2 is equal to x plus constant c. So we get here this as our result. Now we make back our substitutions, and we can write the value of u. What's the value of u? Or my value of u is, we can get here the values of u is given by y is equal to sine square x, sine square u, where we can have here the value of u, we can find it here. So we need more simplification to get the solution in terms of, so we can just stop here and we say this is our solution of the differential equation, which looks very simple. But here we need to take the substitution by substitution, and then we use the trigonometric formulas, and then simplification again using the trigonometric formula, rewriting this one if is a half angle formula for cosine 2u, and then we write the solution for this one. So this is the idea that we are having here, that these questions are, you need the lot of practice for the solving them. You know, if we are, as I am saying repeatedly, we are good in integration, you are good in differential equation.